Hello, everyone. Hello, this is Tiger. So we are at the practice day 3, and today we are going to talk about the inequalities and equations. All right. So before we start, I would just like to talk a little bit about what are inequalities or what are inequations. All right. So basically, for any two numbers, for example, 1 and 2, you can see that they are not equal to each other, right? Previously, we use an equation sign to represent equal to. But of course, if two things are not equal to each other, what symbols are we going to use to express that they are not equal? So first of all, we have the less than sign. And we also have the greater than sign. So for example, I can say 1 is less than 2 or 2 is greater than 1. All right. And well, however, this is very exclusive, which means that, well, if it is 1, you can't use the less than sign. But sometimes when the range of some expressions is inclusive, we have another set of signs, which is essentially just adding a slash or a slant to the less than or greater than sign. And what they represent are just less than or equal to. All right. It means less than or equal to. And of course, the other one would mean greater than or equal to. All right. So basically, that's it for the symbols of the, like inequalities or inequations. And now let's try to see how we can solve these inequalities or inequations. I know not everyone is very familiar with these knowledge. So we'll start from the basics and gradually move on to some specifics of it. All right. So now if we are just taking a look at the first question right here, we have 5x take away 2 less than or equal to 8. All right. So how do we solve it? Basically, how we solve an inequality is just the same as how we solve an equation in many ways, or we can say very much similar, not exactly the same, because I'm just going to talk about what's different later. But for now, we can just think about these two things as, well, very similar to each other, like inequalities and equations. For example, in equations, in linear equations, we have talked about the graph problem, find answer, mnemonic yesterday. So in this one, well, we just need to do, the let part, lump everything together. So we can move the -2 to the right-hand side and it becomes +2. Yeah, we change the sign when we move the side. So we have 5x is less than or equal to 8 adding 2, that's 10. And the next step is like the d, because you don't have to factorize it. So we divide the x coefficient 5 from both sides, and we have x is less than or equal to 2. And that's going to be the answer to this question already. All right. So you can see that it is pretty much similar as the solution of equations. However, since it's a different thing, so definitely there's some difference in it. The major difference between the inequalities and the equations is that, well, if I am taking the opposite number on both sides, I need to swap the sign around, like the less than or greater than sign. I need to swap it into the other direction. Yeah, that's how it works. So let's see how we can do it. All right. So first of all, we can still just try to pretend that it is an equation. So we can do 3. Let's just keep the 3 there because I want a positive x. So I moved x there such that it becomes plus 7x. I moved the 12 to the left-hand side such that it becomes minus 12. So 3 took away 12, that is minus 9, is less than minus 4x adding 7x, that is 3x, which means that, well, minus 9 is smaller than 3x, which means 3x is greater than minus 9. So now I haven't been taking any opposite numbers yet. I'm just, like changing the direction of how I write it, because minus 9 is less than 3x. It means 3x is greater than minus 9. Does it make sense? I'm just writing it in another direction. However, as we do the next step, well, we just, try to divide it by 3 on both sides. And we can see that x is greater than minus 3. No problem at all, right? X is greater than minus 3. However, I'm just going to show you another scenario of how this might run out into. So, for example, if I have decided to move x to the left-hand side, it means that I'm just doing minus 7x adding 4x is smaller than 12 take away 3, right? So minus 3x is smaller than 9. Minus x is smaller than 3. So you might think, okay, so the next step is x smaller than minus 3. If you multiply minus 1 on both sides, right? But then it is exactly the opposite of the answer we just got. That's because if you're taking the opposite number of both sides, which means that you're putting a minus sign in front of both numbers on both sides, the sign in the middle is going to be swapped from one direction to the other. So x would be greater than minus 3. So here is the key step. When you're taking the opposite numbers, make sure that you change the sign. All right? And that is because, well, you can imagine that on a number line like that, say this is 0, all right? So if I have something like a minus x right there, and it is less than 3, when you flip it around, the minus x will go there, becoming x. The 3 would go there, becoming minus 3. So x would be greater than minus 3, all right? That's because you have flipped the whole thing around. You can think about as if we are taking the mirror image about the point 0, such that everything is going to change its direction, right? So a less than sign will become a greater than sign. That's the reason why. Okay, I hope you understand this. If there's any questions, feel free to ask me later. Feel free to ask me after you finish this video, all right? And the next one, we're just trying to solve the inequality here. So if 3 take away 7x is smaller than 12 minus 5 multiplying x take away 1. And from our experience yesterday, we just need to expand the brackets first. So I'm multiplying minus 5 to x and minus 1, which means I have 3 take away 7x. I'm just copying it down. On the right-hand side, I have 12. I have minus 5 times x. That's minus 5x. I have minus 5 times minus 1. That's adding 5. So it means that 3 take away 7x is less than 17 take away 5x. So now if I'm swapping around the terms, that's the reason why I want to keep x positive, such that in most scenarios, I don't have to take the opposite numbers such that I can avoid the mistakes, right? I can avoid any confusions there. So the minus x becomes plus 7x, and the 17 will become minus 17. So the next step is going to be on the left-hand side, 3 take away 17, that's minus 14. On the right-hand side, minus 5x, adding 7x, that's going to be 2x. So minus 14 is less than 2x, which means 2x is greater than minus 14. Now, the last step is to divide the coefficient of x on both sides. So you divide it by 2 on the left, you divide it by 2 on the right. And what you have is x is greater than minus 7. Well, don't forget about the sign as well. All right. So that's the answer to this question. Hopefully it makes sense to you. Now let's take a look at the next one. Well, not much different, to be fair. There's just a little bit of a fraction in there. So what we do is just the same as equations. We are multiplying each and every term inside this equation or inequality by the lowest common multiple of all the denominators. So there's only one denominator here, which is 2. I just need to multiply each side by 2, such that on the left-hand side, the 2 in the numerator and the denominator cancels out. So I have 3 take away x on the left-hand side. And on the right-hand side, I have 2 times x, that is 2x, which means 3 take away x is greater than 2x. In other words, it means that 3 is greater than 3x, because if you just throw this minus x to the right-hand side, lump everything together, 3 will be greater than 3x, and then you divide it by 3 on both sides, such that you know 1 is greater than x, which means x is smaller than 1. All right, so A is going to be the answer right here. Hopefully I'm not going too fast. Hopefully. Do you all get it? Just like solving equations. So if you can master the content yesterday, you can master the content today. No worries at all. Okay. And the next step. Well, the next question is just having more fractions. Like what we did yesterday, we just need to find out the LCM of the denominators first. That's the graph step. Get rid of the fractions. So the LCM of 3 and 6 is going to be equal to 6, right? Because 3 is a factor of 6. So both of them goes into 6. And that's the reason why I need to multiply 6 to each and every term in this inequality, which means that 3 is going to be simplified with 6, and 6 is going to simplify with itself, get some 1s. So we have 2 multiplying 2x, take away 1 in brackets, take away 5x, take away 4 in brackets as well. Because when you're taking it away, you're actually multiplying the whole thing by -1, all right? That's something we have talked about yesterday. And this is also something which you might easily make a mistake in. So just remember, put a pair of brackets in there, all right? And finally, on the right-hand side, we have that is less than or equal to 1 times 6, which is 6. All right, the next step is to simplify this inequality by expanding through the brackets. Get rid of the brackets, the grab step. So 2 times 2x, 2 times -1, and then we have minus times 5x, which is -1 times 5x, essentially, and -1 times -4. So first of all, 2 times 2x, that's 4x, 2 times -1, that's -2, -1 times 5x, that is -5x, minus 1 times minus 4, that is plus 4, and that is less than or equal to 6, which when you lump everything together, you will see that on the left-hand side, we have 4x, take away 5x, that is minus x. Oh, minus x. Minus 2 adding 4, that is adding 2, is less than or equal to 6. Move the adding 2 to the right-hand side, it becomes minus 2. So minus x is less than or equal to 4. Well, but usually when we are trying to solve an equation or an inequality, we won't try to find the value of minus x, right? We want to find the value of x or find the range of x. That's the reason why I need to write it as x. Now I am taking the opposite number of minus x, that is x essentially. So I should also take the opposite number of 4, that is minus 4. However, as for an inequality, it's going to change its sign from less than to greater than. When you take the opposite number, you change the direction of the sign, right? So the opening and the tip, they both go to the other way. All right. So that's it for this question. And then let's take a look at the next one. So the next thing I'm going to talk about related to inequalities is that if you have ever got an inequality chain right there, like this, with more than one inequality sign. So for example, 3 is greater than 1 take away 2x, and 1 take away 2x is greater than 1. That's what it means. So in order to solve it, the best way is to split it up into separate simple inequalities. For example, with only 2 sides, such that we can try to solve 3 is greater than 1, take away 2x first. So taking away 1, and we have 2 is greater than or equal to 2x minus 2x. Now you can just try to, divide the 2 from both sides so that we can see 1 is greater than or equal to minus x, which means x minus x is less than or smaller than less than or equal to 1. That's just flipping it around. I haven't taken the opposite numbers yet. So the last step is to take the opposite number, which minus x becomes x, 1 becomes minus 1, and the sign also changes to greater than or equal to. All right. So that is how it works. Does it make sense? All right. Yet we still have another half of this equation. 1 minus 2x is greater than 1. So 1 minus 2x is greater than or equal to 1, which means that if you just move the 1 around to the other side, you get minus 1. So minus 2x is greater than or equal to 0, which means that minus x is also greater than or equal to 0, as it suggests. However, we are not looking for minus x, we are looking for plus x. So we are dividing both sides by the minus, or, just multiplying both sides by the minus. Doesn't really matter. And it becomes x is smaller than or equal to 0. When you are just trying to take the opposite numbers, you swap the signs, right? For example, if minus x is greater than or equal to 0, it means it's on the right of the number line. And you take the minus or the opposite number of minus x on the number line, it goes to the left side of the number line, taking the mirror image across 0. So it's going to be less than 0. All right. So combining these two solutions, you can see that x is greater than minus 1, x is smaller than 0. So you can just write it as minus 1 is less than or equal to x, and x is less than or equal to 0. So x is smaller than 0, but greater than or smaller than or equal to 0, but greater than or equal to 1. to -1. Sorry. Does it make sense to you? All right, so here we go. That's going to be the last question of today. Well, just like the previous question, it is having a chain of inequalities. So you'd better cut it up before you operate it. So you've got -3 is less than 4x take away 3. And we've also got 4x take away 3 is less than x. So for the first one, you move 3 to the other side, and it becomes +3, right? The -3 becomes +3. So it cancels out with the -3 to be a 0. Now we know that 4x is greater than 0, so it means that x is also greater than 0. All right, and the other side, 4x take away 3 is less than x. So if you just move the -3 to the right-hand side, it becomes +3. If you move the x to the left-hand side, it becomes -x. So 4x take away x, that's 3x, is smaller than +3, which is 3. Now dividing 3, we know x is smaller than 1. Hence, combining these two answers, x is greater than 0, x is smaller than 1. So x is smaller than 1 and greater than 0. All right. Does it make sense to you all? Hopefully you have all mastered the techniques that I'm talking about today. And if you've got any questions, just let me know. All right, send me a message or whatever to let me know. And I'll just try my best to help. All right. So thank you very much for coming today. And tomorrow is going to be the final test of the fast calculation. Good luck, everyone. And I wish you all getting a very outstanding result, or like a high performance, and win all the gifts or something like that. All right. Okay, so that's it for today's lesson. Thank you very much for coming, and I will see you all tomorrow then. All right, bye-bye.